Okay, HTML5 Multimedia streaming. I've given this talk in the past, so it might be a wee bit familiar, but we need something to talk about this week, so I've offered. So the Jisk Media Hub service didn't need to stream videos, but in the days of YouTube, it was kind of like, we need to move forward type thing. So this was something that I kind of pushed. I think it was one of the reasons why I'm still kind of here, sticking about years later. And this is just a quick how to create videos, how it kind of works, and why. Is this working? No? Yeah. So, once upon a time, the front page used to look like that. It's been slightly replaced. This is probably the page I should have done my introduction on. So, at the time of writing this, it's still relevant. This was the kind of matrix of support for native web format support across the browsers. With Microsoft and Safari only really supporting the H.264 codec, which is what you commonly find in, which the everyday man will call an MP4 file. It is patent encumbered, so if you want to use it, you are required to follow the license. Now, if it's free for consumption to the end user, they're happy to let you use that. But that was a response to the potential threat from WebM when it did come about, because that was potentially a free alternative out there that had the same kind of quality and compression rate ratio as H.264. So they relaxed the licenses a wee bit. But if you are a commercial supplier like we were, you have to effectively get in touch with ffmpeg LA and negotiate out a price to use their technologies. Some of the companies behind H.264 are Microsoft, are Apple. You'll probably get, Panasonic and Samsung and folk like that. They've all just grouped together, and ffmpeg LA go out there, collect the royalties, and distribute it amongst the original investors. So Mozilla and Opera being the open source flavors offerings for browsers, they decided to go with Theora, which is an older generation, so a step back from H.264. So, the quality was slightly less, the compression not so great, but at the time that was the only open source video codec offering. But then Google came along and purchased WebM, open sourced it as a rival to the H.264 codec. So Google supports the lot. They did promise to, I think at one point they did promise to support, to drop support for H.264 in order to encourage. I think they were going to use their kind of market muscle to kind of nudge it out the market. But because H.264 is a ubiquitous, you get it in code, it's in chipset, so it's baked into your telly, it's baked into your phone, so you're not using CPU software decoders, so it's a lot more efficient. So they just weren't going to win that, and seem to have backtracked from the promises of only using WebM. On the horizon, we have H.265, which promises same quality, if not better, at half the bit rate. WebM, also known as VP8, I think it is, also has a similar offering on the table. I think it's VP9 or 10. I might get that mixed up. WebM is actually the successor to Theora as well. It was produced by On2 Technologies and purchased by Google during the whole kind of Apple killing Flash HTML5 revolution. And pretty much, everyone does HTML5 video these days. The only problem these days is with DRM, so encrypting and trying to protect your content. There was, at one point, they wanted an extension to the spec to enable kind of downloadable security modules that would, Netflix, it would just be part of the HTML spec, but there was a bit too much. Well, HTML5's open, so I think it's kind of slowed down in that respect. So the common formats, H.264, the audio, so that's the video codec in your MP4 file. AAC is the audio compression format. Effectively the successor to MP3, but MP3 is still, it's hard to shake that one. Theora is the video codec for OGG. Vorbis is the audio compression codec. Vorbis is still good enough. It's actually, it's on par with AAC, so there was no need to produce a new one. There you go, VP8, that's the code name for WebM, so the successor to VP8 is VP9.
Does the AAC audio codec have similar sort of licensing problems?
No, it's free. I don't think it ever did. But I think all the money. MP3 was out there, so they had to compete, I guess. Yeah. And I should also say, where AAC is not, it's not immediately available on, say, Linux platforms. You have to download additional codecs. It's only in the last year or two where Nero have released an AAC codec that in their in-source code form, which then allows you, so we can then download it and compile it. I should say, when using ffmpeg, you're actually using the X264 project, which I think was a VLC sponsored project, and I believe you can use that in place of off-the-shelf kind of H.264 software encoders. I've never actually looked into that one. So, okay, I've probably covered most of this. H.264, industry standard for video compression, most widely used support codec off the lot, commercial users are required to pay royalties. Theora, originally put forward as a default video technology for HTML5, and then when they were coming up against Apple and Microsoft hard-baking support for H.264, they bought a ready-made one, WebM. And again, Theora is really VP6, I think it is actually. Okay. So AAC stands for Advanced Audio Coding, industry standard, successor to MP3, royalty-free distributors. The question mark there is just because everyone's still using MP3 and they should know better, or they don't know better. Vorbis, I think you can actually get a similar sounding Vorbis file at a quarter of the size of an MP3 file. So ffmpeg is the software tool it's got cross-platform support. It's a Swiss Army knife for producing any kind of format. You can query it and it'll spit out everything it supports type thing. At the time I was using ffmpeg to Theora, which is a slight tweak, but I think ffmpeg's come along the way, so it's better. Qt Fast Start, so the way HTML5 streaming works is effectively you're like resuming, so it's like, when you resume a download, you start at a byte offset, so if it gets paused or stops halfway through, you can resume a download, and that's effectively how HTML5 streaming works. What the Qt Fast Start tool does is, before there was proper support for encoding streamable H.264 videos in ffmpeg, they would add a type of kind of index at the end of the file, and what that index did was effectively you have your seek point, so jump to 2 seconds in, 4 seconds in, 6 seconds, and it would tell you the byte offset of that. So what Qt Fast Start does is move that from the end of the file to the beginning of the file, so so the browser effectively just fetches the header of an MP4 file, and then it knows instantly where it wants the byte offset of the file if you want to jump 30 seconds in, 2 hours in, whatever it is. So it's kind of like a chapter kind of list. FLV tool is kind of a similar thing if you're streaming Flash, which was our workaround for not being allowed to use H.264. So effectively, H.264 were priced out of it for the needs of MediaHub. It was about £20,000 for an annual license. So our workaround was to have native support on the browsers that supported it in the form of WebM and Theora, and for your Safari and Internet Explorer browsers we used a Flash fallback, so an FLV video file, and the FLV tool 2 does effectively what Qt Fast Start does. So yeah. So this is just a bit of how to produce an MP4 at a 1 megabyte bit rate. Megabit. Never really got my head around which one that was. So your input file, Now the VPRE specifies, so H.264 comes in different profiles. So basically you've got a baseline and a specification. So it's a specification within the codec, because you've got all these kind of variables that you can tweak for streaming, and the baseline profile is just a standard. So it's baked into the chipset, so it'll support baseline or it'll support higher quality ones, but it'll use slightly different kind of techniques of the specification to squeeze a bit more detail. But obviously you might need a bit more kind of processing power in whatever device you're using. So baseline is just the kind of standard for producing an H.264 video. So the S, that just stands for the ratio that you're compressing it to. I think scale is what that stands for. AC is the ADO codec bitrate to do it at. Video bitrate creates the MP4 file. Qt Fast Start just optimizes the MP4 file by moving that chapter list, that byte range chapter list to the start of the file. And that then makes it streamable, because if you start streaming an H.264 video and you notice you can't stream beyond the kind of bar as it's buffering up, that means you've not optimized it properly for the browser. I mean, effectively, the Theora thing's probably redundant. You could probably do the same with ffmpeg. But right now, actually, WebM has replaced that, so I wouldn't even bother with these things.
With the Qt Fast Start, when it moves the header information to the head, does that make it? I mean, is it still playable in most of the players? Or?
Yeah, all that does is just allows it to be streamable, and you can just seek into the stream effectively. But that Qt Fast Start is now actually a supported flag within ffmpeg, and I'll show you that slightly later. If your FLV, I should actually say, is VP6. So FLV was VP6, Theora was VP7, and WebM was VP8. So it's the same family, just the next generation along. And it's just doing the same thing. I say lib. I use this. This is the open source codec, but actually you get really bad. That open source codec was really bad, and this is what I said was replaced by the Nero codec. I think it's libfdk. Because before you used to have to produce a separate AAC using a proper encoder, and then kind of mux it back in. So this is just some HTML example. There's your poster file. Controls, just being show the controls, preload. Well, I mean, these days with mobiles, I think it's generally best not to preload, so they don't start eating into the mobile data. So this just lists the same, they're all just the same video source but in different formats, and you're listing it in order of preference. So try the MP4 version first. I think you need to do that because if you, it might be a quirk of like Internet Explorer or Safari at the time where they would only try the one source and it wouldn't have this kind of fallback. But the spec suggests fallback, so you can list multiple versions here. The codecs thing, which is a wee bit funky, I think that AVC1 4D blah blah is the baseline encoding that I use. So it's just giving as much information to the client side that they, rather than prefetching the header of the file and trying to determine it themselves. And the MP4A is just, this is the codec, the audio encoding that we use. And you can see the same for the other ones, VP8, Vorbis, Theora, Vorbis, just specifying the codec in advance of fetching it. Oops, let's stop there. So when you use like a Flash, a JavaScript Flash plugin to kind of make it nice and pretty rather than using the default controls, you can embed, that's how you embed your Flash object and your Flash player. So that's where the FLV goes. So effectively, back when everyone was not using Internet Explorer 9, Internet Explorer 7 and 8, JavaScript would determine whether or not there was support for the video element. If there wasn't support, it would go inside it, extract the object, and effectively there's your Flash fallback. And I think actually if you used it on Internet Explorer 7, actually that might be bollocks, because if it doesn't understand the element, I think it might just display it, so it just goes in and displays the object rather than the video element doing what a video element's supposed to do. So yeah, within there, the object, so flow player is your Flash object, and we're just passing it some parameters there. I don't know why I'm repeating the flow player twice. It's probably just what I said to do. Allow full screen, blah blah, and creating a playlist was just, well, the poster was the first item in the playlist. When you clicked play, it would then go to the next one, and there's your video. And the FLV tool 2 is understood by the Flash player. So the flow player object understood pseudo streaming in Flash. Which, I mean, when you saw that, you just thought, well, that's a far better way than having a dedicated media server that just has effectively transcoding on the fly for every single client. You'd need a massive kind of machine for that. So it's a really lightweight way of doing it, and it's now just standard. So same thing, but for the audio element, I like to use M4A to specify that this is an audio file. It's still an MP4 file, but it's an audio file, so let's make the distinction. Same thing for OGA. It's still the same container, it's still an OGV.
So with the Flash thing there, the Flow Player is just the Flash application that's the video player.
Yeah,
right?
yeah. Yeah, and that's just how you get it into the web page. And it's the exact same thing for. It's the same as a video. You're just changing it, swapping it for audio instead of video, and M4A instead of MP4. So this is probably just going to explain a lot of what I've gone over. It's an HTTP-based delivery solution, no special control protocol required, such as RTSP, which is what Real Player and Windows Media probably had. WMA, had their own one. And I think it was just the client would send back a time code, and the server did all the heavy lifting. But now with pseudo streaming, the client knows exactly where to do, because resuming, file download resume is now just baked into web servers. And it's the byte range requests, that's the magic. Works out of the box in most web servers, same functionality as to resume downloads. Seek points are calculated from the file header metadata, where keyframes are mapped to the byte offset rather than the time-based offset. So instead of the client sending back the time offset, the client knows the byte. So you're just resuming a download. And the flash video streaming is just the same thing. It's really, it was a really nice kind of hack or kind of modification to get something working and stuff that's already widely out there. And that's how YouTube used to do it. They probably still do it to some degree. And if you install the relevant... actually I should have said that you flash, if the video asset was free for delivery, you can use an H.264 video codec. So instead of using an FLV file, you can use an MP4 one instead. And you would install a module, an HTTP module on the HTTP server, which effectively Flash would send the start offset, and the module would just look at the header, convert to the byte range offset, and just send that chunk of the video down. So it's kind of, instead of the client figuring out the byte range offset, it's the server. But it's such a lightweight thing, you don't notice it. Server reads keyframe metadata information from resource file header to determine... Okay, I've just said that. And the server modules are available for Apache and Nginx, IIS if you want to do that. There's also PHP scripts can do it, although that opens the file, reads it. I'm not sure how efficient it is, but all you have to do is read the first couple bytes of the file to figure it out. I think actually it's probably the serving of the file through PHP rather than offloading that onto the browser, which is why it's resource heavy. So Flow Player and JW Player support this. Flow Player's, I keep going back, it's quite nice. They keep updating their the look and feel of the skins they use, and you can use do your own skins, brand it. So the H.264 streaming module, so effectively, if you I don't know, I think you could probably just say, screw Flash, I don't need to support that these days, because everyone does support H.264, if they're using Chrome, they're going to support it. If you're on Windows, I think it was i9, did that make it onto Windows 7?
No.
Is it that you've got support for H.264? So, but for posterity or whatever, that's where you get the streaming. But then if you do need to protect your asset using DRM type stuff, you might need modflvx, which is that thing on the previous page where you saw start equals 120. That's going through modflvx, and it's the Flash player that determines that. So when you seek in the bar, it knows the second, passes it, and it's intercepted by modflvx. So yeah, here's just a bit of HTTPD, I should have called that, server configuration. So loading up your modules, add your handlers, so for the file extensions to be routed to the modules. And I'm guessing most of these videos now come out, most of these MIME types now come out of the box. Maybe not for M4A and OGA. Maybe double check that. So Nginx is, alternative and, quickly, it's nipping at the heels of HTTPD and what it can do. High performance, it's been available 12 years. So it's an event-based architecture rather than the other one. So it's quite nimble, I think, because it's gone that way. Rather than forking out different children just to handle load, I think it just reacts as required. And it also supports pseudo streaming, but it also has the added benefit of protecting your assets. Now I do know I've got that in a few slides ahead. So this is how you, here's that tab space thing that we were talking about earlier. It screwed up my tabs. That location thing should be at the start. So Nginx is actually a lot more flexible, and so what it's doing there is you can limit the rate to the bit rate of your video, so you're not pushing more than they can consume. If you're streaming from Amazon Cloud, that's a bit more effect. That's going to cost you money if they download the whole thing and they don't even watch it. So they only watch. You only let them get as much as they can consume. So I think what that limit rate does is they get a burst, so they can, they'll download the first bit in case there's any network interactions, and then after that it will limit the rate to only consume at 500k. So that's as much as they can pull it down. So that's you just assigning it to the modules there. M4A, use the MP4 handler module. So this is magic, this XXL redirect. If you are protecting your assets, you should be using this. What it effectively does is your code can generate an HTTP header. So if you're using Java, if you're creating a Spring application or whatever, is it the response where you chuck in the headers, request.response or whatever it is? You can add your custom header, and it is the XXL redirect. And what you effectively do is you have this protected path. So, the PHP example is explaining that. Your authentication, if it's authenticated, send this to, that's effectively your local path. And this is the kind of special path that we're setting up in Nginx. It's actually pointing to your hidden path. So this protected isn't actually available publicly, and this can be whatever endpoint you want. So this is like neil.php, and it will send, if it includes this header, protected path to your file, it gets intercepted by Nginx, and then it will actually convert it, and it will actually serve up the file that you're wanting, rather than pushing it through PHP or Tomcat or whatever. So, are you following? I think I've been a bit messy in the explanation there. But effectively, if that header exists and the application sends it from behind the proxy, it will get served. If you try to access it directly, but you've been logged out, it will stop working because the application isn't there to do the if authenticated check. So if you're protecting assets, that does it. And the Apache HTTPD can do that, but it can't chain all the other modules that you've kind of got in the block. So I'd discovered that I couldn't use it to protect the assets as well as use like the FLVX module. It's either one or the other. That may have changed in 2.4 or 2.6, but at the time of 2.2, it was a limitation. So yeah, if your cookie expires and you try the same URL path to get your video, you'd get cheeky authenticated fool. So this is just a wee bit of how to interact with a video element through JavaScript. This is vanilla. So grab your video element on the page. That's how you play it, that's how you pause it, and that is how you jump to an offset. So your you could have, that's how we do chapter points. The chapter points knows the offset, and it just sends that to, effectively that's how I do jumping. You can't seek before you've fetched the header. So what this does, so a video element will have states. It'll be like uninitialized. So effectively, if you've already started playing and if you've already done the kind of the groundwork to get the video playing, just jump straight there. If not, effectively you've not pressed play. And what this does is kick off the process of fetching the header, getting the byte range offset information, and this is just an event listener that does, so once the metadata has loaded, you're then able to seek in, because if you attempt to seek before it's actually started downloading the file, it's not going to work. And that's it. So just before I did this, I kicked off an encoding process on our 24-core Super Mac, which will be available for heavy lifting. And I wanted to do this because I haven't said anything about adaptive bit rates, which is now a requirement if you have a native app in the Apple Store. It needs to support adaptive streaming, because that's part of the Apple user experience. They want a polished experience for the user, and their requirements are if your video was under 5 minutes or over 10 megabytes, it's a mix of the two, you will be required to implement adaptive streaming. And adaptive streaming is effectively, you create a video at multiple different bit rates, so that if your network connection drops and you can only consume at 500k rather than 1500k, then you get this seamless transition to a lower bit rate, and the video was just seamless, continuous, without any buffers or interruptions. So as your network picks up, you'll then jump back up to a higher quality one. And somewhere in all this stuff, it'll have the flags to show that. So this is the current way of encoding ffmpeg. It's more up to date than what I showed you, so that's just confirming the aspect ratio of the input source. This map thing allows you, effectively, you can have multiple video streams and audio streams in a video container. So this is just mapping the video to stream 1 of the video stream, and the first stream of the audio thing. So this is shorthand for the video codec. So this is VPX, so this is me creating a WebM thing. This is just some of the, you just Google this shit and that's what they say for the best quality. So that's the 25 frames per second. The G this is kind of important. So effectively, this is our seek points. So the more seek points you have, a seek point is effectively a full rendition of the frame, and everything in between the frames is just, that's the magic, that's the estimation, that's where. Sorry? Just the movements. The movements and all the kinds of tricks, and that's also what the kind of H.264 profiles are. Baseline. It's like, we'll use this technique for higher compression or stuff like that. So effectively, that is a multiple of that. So 25 frames per second, group at 50 frames. So effectively, I've got a seek point every 2 seconds. The more seek points you have, the larger your file is going to be. There's the video bit rate. I was going for about 4 megabits per second for a 720 video. This is streaming stuff. I won't bore you with it, but I think it kind of tells the player, expect this bit rate. You'll work within these confines. This is what to expect. So I think it allows some fine tuning on the decoder end. So we're using Vorbis as the codec. That's the quality. Vorbis doesn't do bit rates, it does qualities on a scale of 1 to 10. 6, I believe, is as close as I could get to about, what did I do for I mean, we all understand 128K when it comes to your MP3s and stuff like that. 96 sucks. But at AAC, 128 is more than enough. And I estimated that 6 was about akin to 128. It's a variable bit rate, so and then it produces your WebM. So this is me now producing a lower resolution one. So this is me producing different resolutions. Nothing different in there. That was WebM. Filter complex. Shit's getting complicated there. That's for when you want to do multiple manipulation. So if, I was using it to add watermarks as well as scale it, and the filter complex is kind of well, either you spin up another process or you chain it on. It's just a more efficient way of encoding things. Rather than working on things separately, it kind of does it in a chain. It took a bit to get your head round. So this is kind of an alias to a filter complex strain. So this is, so before you saw libfaac, which is the really crap open source audio AAC implementation. libfdkaac was released by Nero. Well, the source code is available and it's high quality. It's the best one out there. So, compiling ffmpeg on, well, now we're on CentOS. To do that, you need to separately download and link in the FDK source code if you want to make it available in your build. This cutoff thing, for some reason the default is to have like a low frequency, 8,000 samples per second, which is kind of really, produces a really rubbish audio file. So you have to bump it up to 20,000, which I think is the limit anyway. There you see the FLV tool 2 in use, so it's effectively updating that FLV file with the seek points. This is H.264 encoding. You need, if you want it to work on, I discovered this after I kind of transcoded 70,000 videos, that it didn't work on an iPhone because I hadn't specified a baseline profile which restricts the encoder to, the iPhone supports baseline, also think it supports some of the other ones. And even within that profile, there's multiple kind of levels. So, it affects stuff, it's all these kind of flags that it affects. So there's your 25 seek point every 2 seconds. And there's the bit rate. I'm closing where this line is. This replaces Qt fast start, which I showed you in the slides. So you can just do that now, and in one go get your video ready for streaming on the web. What's this one? This is just a lower bit. Yeah, this is a lower bit rate. So same file, lower bit rate. Here you can see because I'm using a higher quality video, instead of using the baseline profile, I'm using the main, and I'm using level 4.0, whatever that means. Actually, I know what this means. This is an example of producing an adaptive streams. So effectively, I'm now encoding the file at different bit rates, and I'll show you how it all ties together. So effectively, you'll have a playlist produced, and it'll list all the different bit rates that the video is available at. The client then determines which one it supports. So I've decided here clearly to use the profile main, which is the highest quality one. that I'm willing to support anyway. And this is just one take of it. So we're just producing, it's similar to the ones up here, except the output isn't going to be an MP4 file. It's not even going to be an M3, well, it's going to be an M3 U8 file, but it's also going to be a TS file, which is, I think it's an MPEG support, it's an MPEG video container. And initially when the spec was drafted, it would actually create one TS file for every 2 seconds. So your video was actually playing a different file every 2 seconds, but the player just makes it look seamless. And I think the reason TS was used, it's really simple. So the actual overhead for a TS file is quite big. So the more segments you had, or if you had one every 2 seconds, the overhead for that TS file was quite big, and it added quite a lot to your final kind of delivery size. So we're just we're doing the same stuff. Qt faster, blah blah blah. So okay, here we go. So instead of being an MP4 out, I'm using HLS is what Apple call it. HTTP live stream. I think that's what it stands for. So that's the format we're outputting it as. HLS list size, I forget what that means. HLS time, so effectively every 10 seconds the player can then decide whether it remains at the current bit rate or if it needs to drop because network quality is degraded. So every 10, because I used 10 seconds for the reasons I just said. The overhead on a TS file every 2 seconds would just add, so I thought 10 seconds was reasonable. This HLS flag allows it to be produced in a newer interpretation of the specification. So you can now produce a single TS file, which is supported, I think, across the board now, rather than a TS file every 2 seconds. So I think this is version 4 of the spec. And then you create this, but that's effectively just, M3 U8, that's a playlist file, and within that playlist file you get, oh Christ, I didn't think it'd actually last an hour. This is it. I thought it'd be 10 minutes. I'll show you, because I forget what it is. And I'm just doing this for different bit rates, and it's up to you how many bit rates you want to support. I'm just trying to see. So you can see instead of main, I've gone for baseline here. So I think that was 2500. Here I'm going to 1200. Now I'm going to 640. Then I'm 240. And I think I have. Also, Apple require an audio only track. So at a minimum, you can have just the poster file with the audio still playing. And effectively that is the minimum. So effectively you can have one stream and that's the minimum you have to do to get into the App Store. So that's me at the end of the adaptive bitrate bit, and I'll just show you what this produced. So what was it called? Help.csv. What can I find? So that script effectively created all these videos. So these are the video sources I would include within the web. The video element for HTML5 video. There's my fallback flash video for non-compliant browsers, but it's not required these days. That's just there for historical reasons. So I've got HLS high and HLS low. The reason I did that was because on the mobile I offered up the lowest bit rate. So order is the way sets the precedent. So what I've done in HLS high is the first entry is the highest bit rate, but if you're on a mobile, I'll serve you up the lowest video bit rate, and then the client can then determine, depending on the network, it can then it's over to them as to which one it uses. And I'll show you. So within the HLS directory is produced. So the TS files are the video files. That's audio only. So the ffmpeg command produces these two files, and if I can just show you what was there 120? What?
HLS.
Oh right, yeah, okay.
Okay.
Oh man. So ffmpeg produces that, and that's effectively the byte range offset information as well. Version 4 is the one that supports the single file. Otherwise, there would have been hundreds of files in there, and you would have seen it. If you read the spec on the Mac, the Apple developer website, you'll just see examples of like a shit ton of HLS TS files. Now the target duration, I don't think that quite maps up. I think that multiplied by that actually equals the proper time. I don't know, it's not actually representative of the seconds. So here you'll get, this is just the byte range offset and the time sets. And before, it would be the 2 second file, so they've got their different names, and I would show you. So that's that. And I think that, so there's quite a few kind of layers of reference. So each of these correspond obviously to the media file itself. And to bring it all together, you need to create an HLS. I'll show you how. So this effectively brings it all together, and that's what the client downloads. And from that, it can determine, you tell it what the bandwidth is, and it can jump about for the seamless playback, depending on that information.
It'll wait 10 seconds until it's...
Well, it might not wait 10 seconds, but it's not... the kind of switch over point is at 10 seconds.
Right.
So it might know before that. You can reduce that to 5, I think.
Yeah.
It's recommended. I think.
It's not a gradual thing though. I mean, if you were on a mobile, you had a really good connection, it would start with the low one, and then when it switched, it would go to the highest possible one.
Yeah. So if I show you the low, the first one I specify is the 240, and then the other one high. The first one I specify is the highest one. So for desktops, that's one because it's an academic resource. They've probably got a really good connection. So that's why I did that. I mean that Qt fast start. It's called the move atom. If you need to know that metadata in the header file, that could still be used to seek, but there's this additional seek where you jump between the different bit rates that are on offer. So yeah, there's a wee bit of spaghetti in there, but in the end you get this. So ffmpeg will do a lot of the hard work because it gives you the byte range offsets. This was manual, but well, it's a lot simpler to understand.
What's the storage implications of adaptive bitrate?
Yeah. Could have a look.
It looked like about 5 times.
Yeah.
Depends how many you have, doesn't it?
If I do. So, I mean, effectively, if you're streaming on the web, you'd maybe have, if it was a desktop, maybe you'd have that. So, hold on, if I du size HS. The size made it, so
The 480 FLB is bigger than the 720 WebM, so drop that.
yeah, I mean, yeah, it does bloat And you can get away with, actually you can get away, you only have to stream one of the HLS ones. So on the desktop you can just have your source point straight to that. I'm not sure if the TS is recognised, but it's got all the same kind of internals. So yeah, you can just tot that up. Ben, you need to back me up here if I start going off. That. What? It's Windows, right? Well, you can do the maths. Pause the video, do the maths, and whatever combination of that divided by that is your overhead, I guess. Or if not the other way around, if I've got that wrong. So yeah, it does add overhead. I mean, it's kind of like pyramid files, I think.
Yes.
They add 25% or something to the total. It's a similar kind of idea. Yeah. So yeah, because with pyramid TIFFs, you store multiple resolutions and you just kind of walk into the kind of level you're at. And it's the same idea, but yeah, it does bloat. So the minimum is you could just produce an audio track version, and then that's enough to get it in the App Store. So yeah, finished. I only thought that would last 10 minutes. But this has been my 6 years at Adina, so there you go.
An hour, right?
Aye. So any questions, or was that?
So, my question, which I was saving it from the other day, so I've got my DLNA server at home.
And your generic
And
fantasy
Yeah.
TV show.
What should I be encoding stuff as, so that it runs on as, many applications?
H.264. I mean, that's what all these smart TVs support H.264. I think sometimes I've had trouble when it's been coming in the MKV container, and all you would need to do using ffmpeg is let's just use yeah, well everything's encoded in H.264 anyway, but sometimes the MKV.
You said H.265 is coming.
Yeah.
Is that going to be free to use, or is it going to still be encumbered?
Probably. I mean, they've invested in it, and they're baking it into their tellies. They've got market dominance, which is why they're doing it. The video, HTML5 videos, that's everywhere now. It's the replacement. So maybe there might be some pressure to relax. But it was good that Google came with their weight to try and push VP9, but I don't think. They're not. Well, they've got Android. They could bake it into chipsets, but it's whether or not it makes it into the chipset. Yeah.
They don't make the
So say it was an MKV, or yeah, MKV. The video codec, you just copy the audio. Actually, I think it's this way around. Copy, and then
I got my smart TV doesn't recognise the Trusca video container.
What doesn't? Sorry?
My smart TV at home doesn't recognise MKV.
Oh well, that's what you don't need to re-encode it. You just need to repackage it as an MP4. Yeah, that was it. So FF Probe comes along with ffmpeg. It does the same thing, but can do that. It just here you can say there's the video codec, and there's your audio codec. And everything's H.264, and if it doesn't work, just try doing that. All you have to do is it's just the file container. But with Rigel, which is the GNOME DLNA server software that comes with it, I think you can kind of force MKVs to be kind of processed as MP4s type thing.
That's the streamed out.
Yeah, I think they might take it out of the container and then it's just handled by the protocol.
What about encoding on the fly? Is that just unrealistic? Because FFmpeg.
ffmpeg has
won't it?
FF server, I think. Yeah, so you can, and you can output it to a. Well, it probably does that. Well, HLS is supposed to be HTTP live streaming. So yeah, it can produce and you can stream on the fly. I've never done it with FF server, but there's so many good examples of it. I mean, ffmpeg is just. I mean, I think that's what Handbrake uses, isn't it?
It is.
Yeah.
What's behind Handbrake?
Yeah, it's just a GUI. So yeah.